what we're going to do is talk about building a custom scheduler for Kubernetes. How many people know what Kubernetes is? Great, see, this is an advanced talk then. So I'm not going to talk about all the concepts, but I will show Kubernetes in like easy mode so people can get a rough idea about what Kubernetes is, okay? So I'm going to just show it in like the easy mode so we all are on the same page about what Kubernetes is, right? So I'm going to do a live demo really quick of Kubernetes in easy mode, and then we're not going to talk about those low-level details. We're going to talk about the scheduler in particular. And I also want to clear up some concerns about what parts of Kubernetes is the scheduler. A lot of people confuse the components to be one thing, all right? So I have a Kubernetes cluster here, because who doesn't? You should all have one. All right, so here's the Kubernetes cluster. I have 3 nodes in there. So the thing that I want to do is, so in Kubernetes, we have a single contract, and the contract is you have to put your application inside of a container, right? So if you like Ruby, Java, Python, you should probably reconsider those life choices and move to Go. But once you're in Go, even with Go and our ability to do statically linked binaries, we still have to put it in a container. And a lot of people ask, why would I need to put it in a container when I have this statically linked binary? Can I just copy the binary around, right? So the problem with just copying the binary around is that there is no metadata about that binary. What version is that binary, right? So instead of trying to name your binary something special like Go version 2, blah, 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 you just put it in a container and you let your container runtime. So this is why using a Docker image is still important, even though in Golang, we can actually produce these statically linked binaries. So we have this single contract. We produce an image, and we can deploy that image. So for a quick example, I'm going to deploy a very simple container. And this container is going to be called just Nginx, right? So for you're doing demos for containers, you just do Nginx. It's the safest thing you can do. It hardly fails. So Kubernetes kubectl, I'm going to call the run command. So I'm not going to use any of the Kubernetes objects that people usually create. I'm going to let the high-level tools create the objects for me. So I'm going to say, Kubernetes, I want you to run Nginx using a specific container image. Okay, so we're going to use image version 1.10, right? So another PSA here. A lot of people will do this. What version is that? Latest is not a version. Have you ever tried to roll back from latest? How you do it? Can't. So use real tags when you create your images so you can actually roll back, and we'll see why that's important. The other thing I want to do is expose a port that this thing will run on. So here's going to say port 80. All right, so we're going to kick this thing off. So what this will do is, this is something new in Kubernetes. So even those with experience in Kubernetes, Kubernetes will now create deployments by default. So no more replication controllers. They actually got renamed to replica set. You end up creating a deployment. And the deployment is going to give you a lot of things like rolling updates and some other things. So right now what we have is this image running. So if I look at my pods, so they create pods. So now what we have, ignore MySQL, we have this Nginx pod running. So all I have to do is tell Kubernetes to go get this image and keep it running all the time. So given this definition, it's important to know that Kubernetes is declarative, and this is the key to understanding how to create your own scheduler. So if I were to delete this Nginx instance, what do you expect to happen? Some people would say, I get a PagerDuty call, wake up in the middle of the night, and you put it back. But luckily for us, we have a controller that's monitoring the state of the cluster, and yes, it will put it back. And it will hand off a new declaration to our scheduler that will put it in place. So we'll say kubectl, delete pods, and then we give it this pod ID. So we're not changing anything about the cluster state, we're just changing this running pod. Kubernetes will notice this and create another one, right? So there's a bunch of components that work together, and we'll see what that looks like. So this will run, and then we'll start again. The next thing I need to do in Kubernetes is we have this idea of service discovery. So what I can do is create a service object based on the labels that were created for that particular pod. Let's see if this is the right command. Anyone know this command? You will get bonus points. Blah, 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 yeah. Yes, thank you. Why did you guys let me type it all the way out? You're supposed to say, hey, I think you're not going to get that. All right, so look at the labels for this. So it's a pod template hash, but the key label here is run equals Nginx. So we can create a service object that will key off of that label and expose Nginx to the public internet. So right now, my Nginx pod only has a private IP address. So what I'm going to do now is expose it. So I can say kubectl expose my deployment called Nginx, and then I'm going to give it a type. So since I'm running in a cloud provider, I can say type load balancer, and what will happen is this thing will go out and create a load balancer for me. If I was running in a data center, then it will be slightly different. Depending on what my integration is with my data center, maybe I have a custom cloud provider, it will use that, or it will just expose a port on the node. So let's say load balancer. So what will happen here is it's going to create a service object. And when that service object gets created, it's going to go look for all the pods that have run equals nginx. Since we're using this command, it's going to derive the labels it should use from the deployment object. So what I'm going to do now is say kubectl. Let's look at our services. So we say get services. And don't worry about these other ones, but this nginx here. So you'll see that it's pending a public IP address. Inside of my cluster, if you wanted to communicate with this nginx instance, you can just hit it by its domain name, which would be nginx inside your cluster, and you'll be routed to this cluster IP. So that's all internal service discovery. But if we want our clients to be able to hit this particular service, we're going to have to wait until the load balancer gets created. Now, while we're doing that, I'm going to show you a few other things before we jump into this custom scheduler piece, is the things that Kubernetes will allow you to do. So at this point, we're doing all of our operations without logging into servers, right? So it's a completely declarative system. But what happens when we need to do things, like look at the logs? Or let's say we need to get to that private particular pod, and we want to do that. So one thing I'll do is I'll get the pod, and the Kubernetes tooling will allow me to do like a proxy to port 80. So I want to test this before the load balancer is up. So I can say kubectl, give me port forward, to this particular pod. And what I want to do is go and expose a port on my local machine to a port inside of that particular pod. So now anything that I hit on my local host on port 8080 will hit that particular pod that's running inside of my cluster. So I come over here, and we'll just call curl. Right, so great, it works, right? So Kubernetes allows us to not think about the nodes. We're not specifying the machine. We're only targeting the pod that's running our container. So it's a really powerful concept. You don't have to go around handing out SSH keys for people to like screw up production. You can keep them off the servers and still give them access to the things they need to. Once we also have that, we can also look at our logs. So we say kubectl get logs, and I can give it my pod ID, and the API server will go find this wherever server it's running and give me a connection to standard out, and we'll do -f so we can follow. Not get logs, but logs. So just remove this. Okay, so at this point, we're streaming the standard out of the container to my shell. So if we were getting traffic to this, we should see the logs continue to append. And let's see if our service is actually ready. So kubectl get services. So we see that we have a public IP address for this service. If the demo guys are on my side, so far they're not. Let's see what happens here. So we hit this. Yes. All right, so we get nginx that is now running. If we look at our logs, we'll see that we're actually hitting this particular container. Okay? So this is Kubernetes at a very high level. You declare that you want applications to run, right? You guys are awesome. Never post public URLs. There's always a guy ready. All right, so what we'll do for this person, kubectl delete services nginx. All right, so let's get that out of there. He's probably gonna like benchmark the whole thing. Like, don't need a benchmark right now, man. All right, so that's Kubernetes at a high level. It's this declarative system for doing a bunch of things. So now, let's talk about how all that actually works. So this is like an advanced area where I think a lot of people, I'm going to clean up a little bit here. So delete deployment nginx, okay? So it's been a couple of years since nginx has been out, or Kubernetes has been out, and most people have been using it just for deployments, right? That's it. Just like whenever Kubernetes gives me a new feature set, I'll just use it. The true power in Kubernetes lies in its APIs. Everything I just did now was actually done via a bunch of API calls, and every other system, every other component in Kubernetes relies on the same API calls. So there's very little internal implementations that's being used because most of the components are separated in their own daemons that are running, and they communicate over this API. Just to show you a little bit, if I say kubectl get pods, and I do -v equals 9, so we're going to bump the verbosity here, we actually give you the curl equivalent to the commands that we're running. So you can actually see what the curl call will look like and the actual response that you get from Kubernetes, right? So if you're ever building tools on top of Kubernetes, you can use this to figure out how you should write your particular implementation. So, what's that? Yeah, all right, you can use them. I'm going to tear this cluster down after this talk, so don't go have fun with your Bitcoin mining. All right, so let's look at what it takes to build a custom scheduler now. So a couple of things. One, Kubernetes has a declarative model. When you say Kubernetes, run my pod, or you create a pod, nothing's going to actually happen. It will kick off a chain of events, but what we do is we store the state into the API server, right? So the API server stores everything inside of etcd, right? So we get consensus on your desired state. So what we're doing here is basically saying, I would like to run a container called Nginx using this particular container image. Now, given this specification, you can do other things like mount points, declare resources, I need this much CPU, this much memory, and then that will influence the scheduler on how to pick the best node inside of your cluster. How many people actually have experience with schedulers? Oh, that's a requirement to understand this. How do you deploy applications to your servers? You got like scripts going? Raise your hand if you're like fully automated scripts. You're just SCPing binaries? All right, so we gotta do something really quick because we can't have this. Wow, I just like everyone knows what a scheduler is. Like they don't. I'm just gonna update later. I'm not gonna play Pokemon. We're gonna play a very important game. Okay? Has you guys played Tetris? Oh, the rest of you, such poor childhoods. So without a scheduler, you usually get ops people to like, they have like a machines database, AKA spreadsheet. And you give them your application, it's like deploy my app, right? And they go through all the machines and they pick one, okay? That would be the very meat cloud way of doing scheduling. Other than that, most people will have like configuration management and a bunch of scripts, right? So some people have one-click deployments. Raise your hand if you have one-click deployments. This is awesome if you do. All right, so you guys raise your hand. So this is what one-click deployments look like. One-click deployments normally do not account for resource utilization, right? You don't have the one-click deployments go and say, hey, what's currently running? How much resources are being used? And then adjust the script on the fly to pick a new set of nodes. It's like hard-coded, right? So this is your world. Like you're showing off like, dude, we fully automated here. So you do this kind of deal. Hold on, speed it up because your scripts are much faster, right? You hit your one-click deployment. This is what your world looks like. You're like, dude, it's fast. You start at this job, come on. All right, so this is what you do. You're like level 9, right? That's like the master level. So you do one-click deployment. You hit the button, and you go for beer, okay? So this is what you do. Now, to the left is your CPU utilization. To the right is your memory utilization. You notice you're just wasting resources. Now, I work at a cloud provider. We love this. Like, so keep deploying this way. This is going to make your cloud bill super high. So the problem here is that you're not really examining the state of the world as you make your next decision to deploy the app. It's just hard-coded. So you're losing here. So what would a scheduler do here? Right? We should get wristbands. What would a scheduler do? And so the scheduler was going to do something a little bit more intelligent. No, there's a couple of algorithms for scheduling. What we use by default in Kubernetes is bin packing. So in bin packing, we would do something a little simpler. So I'm just going to do this. So I look at the workload, and we try to examine the field. So I'll say, yeah, well, let's place this workload on that node. Let's place this workload on this node. And we keep doing this, right? So this is called bin packing. So we may stack things on a couple of other servers, and you're just like, why is it doing that? It's doing this mainly so we can make room for the right pieces to land in the right place. Now, I know a lot of you are like, he's totally going to screw up in a minute. But I might. So when the right piece shows up, your scheduler is going to probably find the best node in the cluster that's the best fit for that particular workload. And it ends up looking like this, okay? So this is what schedulers give you. It's a more intelligent use of your resources, right? So these are normally called resource schedulers. Now, if you already have an existing environment that's kind of crappy, anybody dealing with Oracle? There's a guy over there. What about Java? All right, so your world is going to look a little different. We're going to be doing from a different starting point. So you're going to be over here. You know, it's not too bad. And if you've got those tools running, you have a bunch of cruft, legacy. Don't be ashamed of legacy. Legacy usually means you make money, right? Starts with like we're all clean, right? So be proud. Your legacy, you make money. Starts with like everything is in Go. Like, you have any customers? No. but it's awesome. But I'm gonna be honest with you guys. If you have a lot of like, I'm gonna call it classic. If you have classic money-making software, you're in a different world. You're gonna come from a different starting point. Your world's gonna look like that. The truth is, Kubernetes can't help you. Nothing we can do. It's a mess, sorry. Quit. Google's hiring. All right, so let's get back to the scheduling thing. So you guys have this idea what the scheduler is. So we want to be efficient with the workload and think about workload placement. So in order to do that, we need to examine the playing field as the workload comes in and then choose the best machine that's the best fit for our particular workload. So let's look at that in practice. All right, so we have this state. It goes into the API server. So this is like the piece falling onto the Tetris board. Now the API server says this piece is agreed upon that this is the spec that you want. Now we have this thing that will actually run our particular workloads. So if you've ever used Kubernetes, it seems very complicated is because people explain in a very complicated way. In Kubernetes, there's effectively only two things, right? There's this idea of a pod, which has one or more containers. We take that pod and we put it in the API server. And then we have the kubelet that executes those pods. Define and run. Now, how we get that to actually work is where all the other components come into play, right? Your application produces logs, so we need something to pull the logs out. So when we create a node in Kubernetes, it will attach to the API server and say, hey, what should I be running? We never talk to the nodes directly, so you never run anything on a specific node. You give it to the API server. So how do we take this definition and give it to the server? This is this active scheduling. So we attach a scheduler to the API. So any scheduler that you would build, you would basically be a first-class citizen because you actually live in the same place where Kubernetes default scheduler lives. So the goal of the scheduler at this point is to list all of the nodes and maybe look at what's running on them. So a couple API calls we'll see in the code. We list all the nodes, and then we list all the pods, and then we just map what's running there. We do a little bit of math, and we see where our resources are. Once you make a decision, your goal is only to bind where that pod should run, and Kubernetes takes care of the rest. So the minute you write that node name onto the particular pod, it will now be running on that particular node. That's it. Now, in the case of those deployments and replication controllers that scale things horizontally, their goal is to take this pod specification as a template, and when you say you want to go from 1 to 3 of those, its job is to create 3 individual pods and pushes it essentially to the API server, which will have them queued up. And the scheduler will just pull unbound pods and map them to the server. All right, so our goal now is also Kubernetes supports multiple schedulers. So people say, man, I heard Kubernetes scheduler sucks. And they say, what part of it sucks, right? Because it's a complete system, and we do have a very elementary default scheduler that does things like how much memory, CPU, a few predicates, and then places you to the best fit, right? You just have to have something out of the box. But the truth is, the default scheduler is not part of core Kubernetes. It actually lives in a third-party directory. It did for a long time. Kubernetes also has multiple schedulers. We have another scheduler that you would use for things like logging daemons. So imagine if you have a logging agent that you would like to run on every server. We have a different scheduler where you can just say, hey, any node that has these labels, or all nodes, run this particular workload. And then that thing actually goes through a different flow. That thing will just look at all the nodes, compare labels, and then do the binding itself. If you want a better scheduler or a more advanced scheduler or additional predicates, you can totally write those yourself, and the system tries to make that easy. All right, so let's talk about making a custom scheduler. So we need a workload. And the workload that we're going to be using is this app called DevNation. All it is just a simple pod, connects to a database, and it gives us a little bit about its ID and its IP address. So the first thing that we're going to do is look at our workload. And I'm going to just deploy it so we can be all on the same page. So here's what a deployment definition looks like in Kubernetes. Right here, we're giving our app a couple of labels, app and its track. So these will be used for service discovery purposes. The important bit here is this template. So this template will have metadata, and the labels always have to match the babysitter, so we can know what pods belong to this particular controller. So if we say that we want 3 copies of this job will be to look at our API server and see how many are running. If there's too little, we create some new ones. And then down here is the actual containers we want to run. So in this case, we're going to run this DevNation container at version 100, and we're going to connect to our database using secrets. I'm not going to talk too much about this database stuff, but it's really powerful because in Kubernetes, usually it solves the problem around how do I get configuration to my containers. If you have some folks that don't really have enough objects to represent things like secrets or configuration, they'll tell you to bake your secrets in the container. Anyone see a problem with that? It's not good. Yeah, like if you check your SSH keys into GitHub, okay? How many people have done that actually? You lie, you can just nod your head. The other thing too is this help Z probe. We want to make sure that anything that we deploy is actually healthy before we add it to our service discovery. So it's a very simple app. So let's just deploy it really quick and we'll see how this works. So it's kubectl, git pods, and we have MySQL running because I just wanted to start the database before we started having our apps. So MySQL has a DNS entry in place so that internally I can hit MySQL and connect to my database with the right credentials. You can't see my credentials. Those are actually done as secrets. So everything you just saw there with the environment variables, they're being populated from our secret store that is only managed by the kubelet that's running on all the agent machines. So right now what we're going to do is go ahead and run. We're going to create the DevNation app. So deployments, DevNation. So we should get one copy of DevNation running at version 1.1 or 1.0. All right, so at this point, our scheduler has picked this thing up and found the best place to run it. So I'll do dash wide so we can actually see where it's going. So we see that it's now running on one of our nodes in the cluster. The name doesn't really matter. It's just the best fit at this particular time. Now, if I were to adjust my spec, and we increase it to, someone give me a number. Very responsible number. Someone said 50. I was like, all right, so 3 works. So let's say kubectl apply. We're going to update the definition of this thing. All right, so at this point, Kubernetes is going to do a rolling update for this. You know, it would have been, so it just scaled it. So now we have 3 of these. I also have a service in place for this. So DevNation has a service, and what this service does, kubectl describe service for DevNation, and it just tracks all the pods that have the right label. So we see we have 3 endpoints here, right? There's a total of 3. I'm going to bump that number again so we can see what happens when we increase that number. So we can go from 3 to 5, okay? And then we'll do the apply again. And once these things pass their health check, they will show up as backends in our endpoint automatically. We have a separate controller that's monitoring these things. So my guess is they're not healthy yet. Wi-Fi, yes. All right, so these will become ready at some point once they pass their health checks. And once that happens, they will show up in my backend. Great. And we see that we automatically have 5 of these running. Yes. All right, so you see 3 plus 2 more. So we'll go to this public IP address to see what happens. All right, there's our DevNation app. Okay, so it's running version 1.0, and if we just kind of try to round robin, so we get round robin between all the pods. So the last thing we're going to do before we show our scheduler in action is do an update. So we'll do an update of this to version 2.0. Okay. So if you had latest here, that would be really sad about how you would actually have to do this, because you can update any of the metadata, it would all be the same. You would just have to kill everything and roll it again. So doing that, we can do another apply. And what will happen is Kubernetes is going to automatically pull these things down and cycle out all of our images. I don't know why it's complaining. Let's do a watch here. That just looks scary, doesn't it? All right, it's actually pulling these things down. Some are running, they're pending. Now, as this is happening, we should be able to refresh here. Come on, Chrome, don't stick to DNS. Yes. All right, cool. So eventually, these will all roll to 2.0. Let's see how far we are. All right, so as they become ready and come online, they will automatically be added to my load balancer. The ones that aren't ready will not be added, so we won't see any 500 errors when we go there. So let's delete that and create our own scheduler. So here's what you got to do in Kubernetes. So let's delete deployment dev nation. Just want to clean this up so we don't have a bunch of noise. So we need to do a couple of things. In order to support parallel schedulers in Kubernetes, we have to give our new workloads an annotation that says it should be picked up by a different scheduler. So ideally, we want our default scheduler to ignore the new workloads. So in order to do that, we have to add an annotation. So let's do deployment, and we'll do dev nation custom. So here, when we create these workloads, we're going to use this annotation. So this annotation, it's an alpha feature. It's probably beta now. So this scheduler should only be picked up by schedulers named Hightower, okay? So you should definitely name the schedulers after yourself. So the first dev that writes the scheduler gets to name the scheduler. So this is the Hightower scheduler. That's a pretty cool name, isn't it? Are you running the Hightower scheduler? Yeah. Okay. So the default scheduler will ignore this. So we have 3 copies of this thing. And we're going to be running, let's make sure we get the right version. So let's look at what happens in Kubernetes. So we want 3 copies of it, and we want to run version 2.0. Okay? So I'll say kubectl create -f deployments dev nation custom. So remember, these things are decoupled. The deployment controller, the replication controller, and the scheduler. The replication controller that sits underneath will create 3 of these pods that need to be bound somewhere. So if we say get pods, they're just going to pin forever. This is why it's important to understand that this is fully declarative. You're not running any commands. So some people want to do things like a dry run or hit run and want logs to be spewed back to them to tell them, is my workload running or not? The only thing we can guarantee you is that we know what you want, you've declared your state, and at some point, a scheduler, if running, will pick this up and run. Right? So this is still pending. So what kind of code do we need to write to make this happen? So we do have an API. There's not a lot of docs around Kubernetes in general, but especially the API. So how would we actually write? Someone's laughing because they went through the pain. We're trying to fix it. Please bear with us. So here's my code for my scheduler. So I'm going to make this one really simple so we can kind of follow what's going on here. So of course, you give your scheduler a name. So the goal here is that, how many developers do this? Do you print like a log message that your application's starting? Why is this important? I've seen a sysadmin like deploy an app and like nothing happens. I don't know if it's running or not. That log statement is super important. So I do it all the time, especially in a tool like Kubernetes. You don't want those things just to sit there. You don't know if this is running or not. The next thing I want to do here is get unscheduled pods, okay? So I'm going to show you what the API looks like in Kubernetes for these things. I'm just going to use GitHub to browse around. The code is on GitHub. I definitely want you guys to kind of look at it and maybe make your own scheduler and make them a little bit better. So we have this function called get pods, or get unscheduled pods, right? So everything is specified in, we have an HTTP API for everything. You're going to notice I'm using localhost here. I'm going to show you why in a minute. So here I just want to get all the unscheduled pods. So currently, if I were to list all the pods that we just did, none of them are bound to any server. That means they're just pending. So if I make an API call to Kubernetes here, and in order to do this correctly, I list all pods, and the only indication you have in Kubernetes that is not scheduled to a node, if its node name fill is blank. I think we could probably do a better job in the API here, but this is your only indicator that this pod is not bound to anything. So you use a filter, and you get all the things that do not have a node name set. You gophers out there, don't judge my source code here. This is an example app, okay? So I get the response back, and what I will get back from Kubernetes is a big pod list, okay? So this pod list, if you want to look at it from the command line, kubectl get pods -output JSON, or maybe do YAML so it can be a little bit more readable. So this is what you're going to get back, right? You're going to get a list of these things that has all this metadata, right? So we'll grab that list of all of our unbound pods. And then what we want to do is filter that list of pods for our scheduler name. That's the contract. So if you do the wrong thing, like create a scheduler that starts scheduling things that weren't assigned to you, then you're screwed, right? So if you put parallel schedulers in place and they start fighting for workloads, it's going to be some weird things happening. Now, Kubernetes will prevent them from binding to the same node because we actually try to take care of that with our binding endpoint. Sometimes you have race conditions, but the controllers will go ahead and clean those up on its event loops. So here we have our unscheduled pods. We do our filtering for our schedule name, and just return back the list of unscheduled pods, all right? Filtered by our filter for our scheduler, all right? So the next thing we need to do is we'll go back to main, So once we have the unscheduled pods, if we don't have anything, I'm just printing here that there's nothing to schedule. The next thing we want to do is do a fitness function. So this is what the default Kubernetes scheduler does. And I'm just doing this with HTTP, but basically we want to just take our pod that we found. So for each pod that we get, we're going to grab the first one, and then we're just going to run our fitness function on it. So for most people, your first venture into scheduling will be like this idea of a fitness function. So we'll go here and we'll look for the fit function. And these things are pretty simple. So here I'm going to give it the pod object, and I want to pass back a list of nodes that can actually run that particular pod, CPU and memory requirements and so forth. So I'll call the API endpoint called get nodes, and if you look at that code, it's just an HTTP call, very similar to what we saw for get pods. And then I want to get all the running pods in the cluster. So actually building this external scheduler, I don't think a lot of people have done and give feedback. We can make this a lot simpler. We should be able to get an object back that has the mapping done. So what I'm doing here is getting all the nodes, getting all the pods independently, and I'm having to map them back myself, right? So this is a bit of a pain point. So I map these all back, and I start to map them based on resource utilization, CPU requirements, and those things. So once I have this map, we'll go through, there's a bunch of stuff here. I'm going to show you this for a second. We have some weird, like, naming conventions on how we do CPU cores and memory. It's going to make you sad. Right? We have a whole library to do math about how much CPU and memory is actually used on the nodes. The reason for that, we wanted to make it so complicated so people wouldn't try to do like basic accounting of memory and say, hey, we're just going to say like there's 10 megs of RAM. It's a little bit more nuanced than that on the actual server side. So we have a library that actually does all the math here. I'm not using it, so I'm going to just stick to something simple like managing the amount of CPU that I use. But when you venture into this world, just know that we have a library that you're going to have to use to compare how much CPU you need and how much is actually used. This is the first thing that tripped me up. So I'm going to go through here and filter through the nodes and figure out if any of the nodes have enough space required to actually run my workload. And then I'm just going to return that list of nodes. So once I have that, what's the whole point of a custom scheduler? So we can do something custom. So we have the list of nodes that can actually fit this, and then I'm going to introduce a new fitness function called the best price. So I'm going to take all those nodes, I'm going to look for a special annotation to tell me which one has the best price. So here's the last bit of code we're going to look at before we actually try to run this thing. So we look at our best price. So this is just your function now. You take the list of nodes that have already been filtered out that they can actually run your workload, and then what we're going to do is like figure out some data from annotation. So we're going to look for a cost annotation that we're going to put on every node, okay? And what we want to do is figure out which of these nodes is the either more expensive or cheapest, and then we're just going to return that back as the preferred node to run this workload. That's all I'm doing here is just getting the best price and return it. So I give it a list of nodes, and I just want to turn back a single node, and that node will be used to do the binding, right? So that is our fitness function. So we just do the normal stuff, we add our custom logic here, and the last thing we need to do is do the actual binding. So down here, I call the last API call, which is to bind that pod to that particular node. Let's look at that, and then we're going to run our scheduler. And this bind call is really not documented very much. It's definitely in our Swagger output, but it's really hard to find. You have to create this binding object. So we take the name of our pod and its type, and we give it to a kind called node, and we give it the node name that we want. We submit this to the cluster, and the first scheduler that does this for a particular pod gets to write that node name in place. So this is the last mile that you need to do. So a lot of integrations in Kubernetes, this is what they're essentially doing. Doing a bunch of logic, gathering data from Kubernetes API, and then once you make your own decision, however you want to make your decision, you call this binding endpoint, and Kubernetes will take care of the rest, okay? So let's run this in action. All right, so I'm going to kubectl get pods. All right, so let's delete this controller so we can see what this thing looks like before it starts. So let's delete deployment, dev nation, custom. All right, so I don't want anything running for a second. kubectl get pods. All right, so there's nothing running. So let's kick off our scheduler. So we'll just do it from here. So we have the source code. We'll just do a go build. And now we have our scheduler binary, and we're just going to run it. So we need to authenticate. In Kubernetes, when you start off writing integrations with Kubernetes, Authenticating is really complex. I'm going to show you what these authentication files look like that you need to parse. Be ready with your screen captures. All right, so that's big, right? You saw that? Yeah. So you actually have to build apps that know how to parse our custom config for connected to the API server. The other thing you can do is run kubeproxy. So if I say kubectl proxy, this thing will give me a proxy and authenticate for me and all the permissions that my config file has, and I can just actually hit it over localhost. So this is going to be important when we deploy our scheduler into the cluster. So with this authenticated proxy in place, I can just run my scheduler. So now I'm connected to Kubernetes, and I'm trying to find pods. I'm just printing out, and I'm just doing a loop instead of a while so we can actually see things printed. So there's no work for me to do. So if I create kubectl, create -f, deployments, and we'll do our custom deployment again. So now that this thing is in place, we'll see that our scheduler will pick them up and find the cheapest node in the infrastructure and schedule them there, right? So if it wasn't running, you saw what that looked like before, it would just be pending, okay? And the nice thing that having our service decoupled from the scheduling logic, so now that that's in place, all of those new pods are now running underneath my service discovery. So when you write your scheduler in Kubernetes, you don't have to concern yourself with service discovery, controllers, healing things that fall down. None of that is your concern. The controllers will take care of all of that for you. The only thing you need to do is make a binding decision. That's how simple it is to make a scheduler in Kubernetes. So now the next question is, you probably don't want to run your company scheduler from your laptop, okay? This would be bad. So how do you deploy the scheduler, your custom scheduler, to Kubernetes? The thing we need to do is what? What's the first thing we need to do? Yeah, Docker. So you're not going to SCP your scheduler binary to the server. Don't do that. I'm going to create a Docker file for it. And so this is a static link binary, so this is all I need. So this scheduler Docker container is about 4 megs compressed. I push this to the Docker hub. And so once I have my scheduler in the container, I give it a version. I need to deploy my scheduler. So let's look at this really quick. So I'm going to delete these again, deployments, because I want to see this in action. I just want to clear things out so we can see things. All right, great. So what we want to do here now is like create a deployment for our scheduler. Okay. Now who's going to schedule our scheduler? The default scheduler, that's right. So since we haven't given an annotation that we want this deployment, because this is just another service in Kubernetes, we want the default scheduler to handle this one. And notice what I'm doing here in my pod. So people ask a lot, why does Kubernetes have pods? What's the point? Why not just run a single container? The thing is, there are services that are tightly coupled and belong together. And in this case, that kubectl proxy command, so inside of Kubernetes, when we deploy a pod, we can present it a service account. Now, the code that I wrote on my Golang side, I don't want to learn how to parse that config and deal with it. So what I do is I make a type dependency on the kubelet. So the kubelet will run in daemon mode because I pass it an argument called proxy, just like I did on my laptop. Now, given that one flag, if you look inside of that container for the kubelet, you'll see that there is a mounted service config there. The kubelet will find it, or the kubectl command line tool will find it, connect to the API server, and give me a local host connection to the API server. So I don't have to modify my code to do this. This is why we have pods in Kubernetes. We need to deploy our scheduler tightly coupled. So those two things together logically equal our particular scheduler. So now let's deploy this thing. So kubectl create -f deployments scheduler. So now Kubernetes will keep our custom schedulers running. So we're just going to pull down that container. We see that there's two of two things running. So we have kubectl, and we have our scheduler running. So everything looks good. So at this point, if we create our custom workload again, remember we get pods. Remember we can use the logs command. And since there's two items in here, you'll see the error that prints out. We need to specify, do we want to look at the kubelet's logs or our scheduler's logs? So we get a little bit more specific with the container. We give it -f, and we can see that it's already started to do work. So now our scheduler is online, and now we have parallel schedulers inside of Kubernetes. And let's verify that these things are running. They are. Refresh our web browser. Cool, and that's it. And that's how you do a custom scheduler in Kubernetes. Thank you.